Yeah, Wayne's still sick. Something that we don't want him to be here for.
Yeah.
So we really, I doubt it. If he has 104 fever, he's probably like, your body doesn't function well when it's not right around whatever the temperature is supposed to be. All right, so what we want to do on this problem is find the max area of the region that is shown by that. What does that look like? Parabola, yes. What is it going to do? Is it going to open upwards or downwards? All right. It's going to look something like that. I really don't care exactly how it looks. There's no reason to figure out the exact look of it. Okay? What we need to find out is the area. It means that area. In between the curve and the x-axis. Like the part that you can shade in without like keeping going forever and ever and ever. Does that make sense? Well, this down here, like it'll never stop. And so they're not looking at it. When they would be looking at it would be like if they were doing that part. Does that make sense? In between the curve and the x-axis. And so if you have a curve like that does this, you would be looking at this area and that area and that area. Okay? All right. So the way that you find the area, like they've told you find the area from this value to this value, right? They've given you endpoints, but on this one they're not going to give you the endpoints. So you find the endpoints by finding the derivative and setting it equal to 0. So what would be the derivative? Does that make sense? Okay, so we set that equal to 0. Oh, wait. Right. I skipped to the next step. That's not your endpoint. That's your maximum. That's the second step. Yeah. That's at 1. In case you don't know how to graph it, that's how you would graph it. All right. Find the endpoints. You set the original one. It's equal to 0. Sorry. Usually they're going to be not weird numbers, but I think this one ends up being a weird number. So how would we factor this? Remove, replace, reduce. Okay, what is negative 3 times 2? Negative 6. Is there anything that multiplies to give you negative 6 and adds to give you 6? No, there's nothing. So we don't want to do factoring. What do we want to do instead? You could, I'm going to prefer to do quadratic over completing the square, but you can do completing the square. If you don't remember the quadratic formula, if you don't know it, you need to learn it. You're going to use it because there will be ones that either you don't want to do remove, replace, reduce, or that you just can't think of how to factor it. Does that make sense? Okay. It doesn't care how you get to the x values. It just wants you to figure out what they are. So what is negative b? Plus or minus the square root. 36 minus, what is 4 times negative 3? Negative 12 times 2. So minus negative 24 is plus 24 over negative 6. Does that make sense? What is 36 plus 24?
60.
Does that make sense? Hold. That's one of them, right? And the other one is, yeah, you can reduce both of them. Like the square root of 6 reduces. But Josh brought up the negative, so I'm going to go ahead and take care of that. Negative 6 divided by negative 6. Okay, the square root of 60. It's the same thing as what? 60. Yeah? What is the square root of 4?
2.
Do we know the square root of 15? Okay, so instead of 60, we have 2 square roots of 15. 2 over negative 6. Negative 1/3, so square root of 15 over 3. Does that make sense? And then it's a 1 plus the square root of 15 over 3. Those are your two endpoints. Does that make sense? Okay, so those are our endpoints. That is that value and that value. I'm going to say that that one is the 1 minus square root of 15 over 3, and that one's the 1 plus square root of 15 over 3. How do I know that?
Yeah.
This is obviously a positive number, right?
Yes.
Is this one going to be smaller or larger? It's going to be smaller. If you can't figure that out just by looking at them, plug them in and see what the decimals are. Does that make sense? Okay. Then you're going to find your critical number, which I started by doing, which is 1. It tells me that it's a maximum. You really don't need to do that on most of them because you can kind of get the basic shape of the graph. Does that make sense? But if you're like completely stuck on what it looks like, you go to those two numbers and, oh, it's a 1, and it's going to be a maximum. From that step, you do the second derivative, and it'll tell you if the critical number, the 1, is a max or min. Okay, the second derivative is negative 6. Since it's negative, it is a maximum. It's the opposite of what you think. Since the second derivative is negative, that means that that critical number 1 is a maximum. No. We only care about the positive or negative value of it. Usually, you're not going to have to do step 2 and 3. Most of the time. That's really just for your benefit to figure out the graph. So if you can kind of get the basic shape of it, we don't care about the actual like perfect shape of the graph. But as long as you can get the basic shape, you don't always have to do those two. Does that make sense? Okay. So to find the max area, what would I do? That number, and then that area thing. Are we going to actually do that? No. That's just what you would do. I'm not going to, no, well, I mean, if you, that's what you would do. Like you would actually integrate it and then plug in 1 minus square root of 15 over 3 and 1 plus square root of 15 over 3, which is what you've been doing. But they have already, the A was what they gave you up here. Whatever that is your actual answer. It'd be a number. Does that make sense? Okay. So that's what you have been doing. This part is why I'm not going to keep going. But they won't always give you the endpoints. And that's what you had to find on this one. Does that make sense? This part is what you've been doing when it says find the area of this from 1 to 5 or negative 3 to 2 or whatever. Any questions on that part? Okay. All right. So this is should look familiar. Mr. Wall has 100 yards of fence. He wants to form a rectangular field enclosed on 3 sides by the fence and on 1 side by a river whose banks are straight. Does that part sound familiar? Y'all remember doing those? Now what we're going to do, we're going to find the greatest area that that fence can enclose. Maybe. Jeremiah says it's going to be a square. All right, so this is a little bit different. First off, you have to figure out your formula for the fence. I told you whenever we start with these, I would draw a picture. So I've got a picture of a river, and then I have a fence. Does that make sense? What do I know about these two? Right? What do I know about this one, and that one? So I'm going to make that y. X plus y plus x equals 100, right? Do y'all remember doing this part? Okay, so now we're looking at area. How do I find the area of that figure? X times y. But what is y? Which is what? You remember doing this part? Okay, that you've done before, like that exact same kind of thing. Okay, that part hasn't changed. To find the greatest area, you have to do what? Any ideas? We're going to okay, we can do derivatives. Do you agree? Yes. Okay. We also need to do what? Oh. Okay. Set the original to 0 and set the derivative to 0. I'll come over here. What would we do here? Take out a 2x and you're left with 50 minus x. Does that make sense? So x equals what? All right, on this one. You should get x equals 25. You set it equal to 0. Does that make sense? So those are our critical numbers and our max or min. We don't know what they are really. Really, we don't need the graph of this one. We don't care what it is. We're looking for the greatest area. Does that make sense? Okay. What is that equation? What does that tell us? The area. And we want to see what the area is going to be at 0, 50, and 25. Whichever one of those is biggest gives you the greatest area. The reason you don't have to check any other numbers, those are your critical numbers. So they're either going to be the minimums or the maximum, or just some random critical number. Does that make sense? So you don't have to check anything else because those are the important numbers. So don't start plugging in just random numbers. Like, there's a reason you got 0, 25, and 50. Those are the numbers you want to check. Do you have to show me your work that you tried 0, 50, and 25? Like, do you have to write it out, like plug it in and do the work by hand? No. What is the area of 0 if you plug in 0? 0 times 0? I mean, 100 times 0 minus 0? What is the area for 20, what? 1250? And what is the area if you plug in 50? Huh, that's easy. Which one is maximum? This one. Well, on this one it just says the area. So the max area would be 1250. Well, no, what it might ask, what dimensions would give you the largest area? Oh, okay. What would be the dimensions then? $25 by 50 would be the dimensions. So sometimes it'll ask you for the area, sometimes it'll ask you for the dimensions. It just depends on the question. Does that make sense? Any questions there? Okay. All right. Don't remember these back from like Algebra 2, where it would say like, you have these two numbers that add up to this and these two that do this, like what are the numbers? Okay. It's kind of, yeah, you could just guess and check on those. Same with these, you can guess and check. Yeah, these, you can guess and check, but sometimes they're going to be more difficult. Like this one, it wouldn't be too bad to guess and check, really. Yeah, you could use, it just says two positive numbers. But yeah, if you have you could use negative no wait, it says positive numbers, so never mind. If it said just two integers, then it could be positive or negative. But it says only positive integers, so our x and our y, or a and b, or whatever you want them to be, have to be positive. Does that make sense? Okay, so what equation could I make from whose sum is 8? Okay, what equation could I make from product is a maximum? Is a maximum. It's the most. The product, you can say P instead of M. We don't really care. It's just a letter. Does that make sense? Okay, so we want the maximum possible. Right now, this is in terms of X and Y. How could I get it in terms of only one? No. If I use X, what does Y equal? Does that make sense? You always want your equations in one variable, not in two. So what is the maximum actually? And then, any ideas what we're going to do? No. Well, it'd just be 0. The derivative. If you set this one equal to 0, whoa. You get x equals 0 or x equals 8. But 0 isn't actually a positive number. If you took the derivative, what would it be? And then what do you do with it? So what does x have to be? Does that make sense? So if x is 4, y is 4. Does that make sense? And the maximum product of two numbers that add up to 8 is 16. 3 plus 5 is what? 2 plus 6? 1 plus 7? Like 1, well, like I'm doing numbers that add up to 8, and then the product is, he was, Jeremiah was,
Wait a second. 2 and 2 is 4.
2 plus 6, the product is 12. 1 plus 7, the product is 7. 0 plus 8, the product is 0. That's why you don't have to worry about the critical number, like the endpoints on this one, because 0 times anything isn't going to give you a max area. A max product. Do what? You can, just to check it, but on those you don't have to usually. Yes. Okay. Okay. Any questions on this one? Okay. You should remember this type of problem. Make an open top box by cutting squares from each corner, folding up the edges. We're going to find the value of x that results in the largest possible volume, and we're going to find the volume. So we got to find both the dimensions and the actual max volume. Do y'all remember how to draw these pictures? What do they look like? Not a square, but close enough. Right? What is going to be the length here? And then after you take out the squares, what is it going to be? Minus x? There are two x's, this one and this one. Does that make sense? Okay. What is going to be the length of that one? It was 15, and then you're going to take out two x's. Does that make sense? So now we're looking for volume. Well, how are you going to find the volume of that figure? That's it? Length times width times height. Any questions on that part? Do y'all understand why it's not x squared? Any questions? Okay. So now we have to factor it out. 15 times 12. 15 times negative 2x. 2 times 12. And then plus 4x squared. Does that make sense? If you can do this, go from here to this step before, like without writing it down, that's fine. Like if you don't need to write this step down, you can do that. I don't care. I tend to write it down just so that I don't make a mistake. I'm really bad at addition. Like 3.5 plus 3.5 plus 3.5. I can't do anymore. I get that wrong. Mom was like, "You're a math teacher." I was like, "Yeah, I know. I can't do simple addition." Yeah. So anyway, any questions on that one? That part? Okay. So that's your formula for what? The volume. How do we figure out what's going to give us the maximum volume? The derivative, yes. What is the derivative of this equation? Now what do we have to do? Okay, I'm going to rewrite it 12x squared minus 108 of x plus 180. And now what do we need to do? Yeah, what are we going to do though? Yeah, how are we going to do that? Like, you can factor? Okay. 12 times 12 times 15. Does that make sense? Will this part factor? One and 15, do those add up to 9? 2 and, okay, 3 and, okay. So what do we need to do instead? Quadratic formula. By factoring out the 12, you made the quadratic formula easier because you have smaller numbers. Does that make sense? So don't go back and be like, oh, I can't factor it, and go back here. Like, go back here. Like, just use these numbers. Does that make sense? Instead of having the bigger numbers, I mean, if you want to, that's fine, but. All right, so 9 plus or minus the square root of. What is my A? Is it the 12? Okay. Okay. Just want to make sure. Do you agree with that part? Okay. Do I know which of those numbers is positive and which is negative? Like off the top of my head? The square root of 21, do I know what that is? I mean, it's close to in between 4 and 5, but I don't really know exactly what it is. So figure out what the decimals are. Do you agree with those two numbers? Does that make sense? Any questions so far? Okay, so now how do I find my max volume? Okay, try the 6.79. Where am I going to plug it in? This one? That one. I like to circle and box stuff on my paper because sometimes I lose track of where they are. So if I circle and box it, it doesn't necessarily mean it's the actual answer. It's just something that's important. Yeah, I can't follow Jordan's system. I'm sorry. Okay, what did you get when you plugged in the 6 point whatever? Is volume supposed to be negative? So we're going to use the 2.21. Why? Well, you don't know. It could not work too, I guess. Oh. Okay. And if you do the volume of the 2.21, what do you get? You agree? Okay. So that is our max volume, right? 177.23. So it said find the value of x that results in the largest possible volume. Which one is that? And find that volume. Yeah. You can plug in 3, yeah. I get 162. So I'll plug in. Does that make sense? Okay, why would the 6 point, what was it, 6 point something? Okay, why would 6 and 3/4 basically not work? Why did... Nope, nope, nope. This is a length of 12, right? Halfway is 6, correct? Can we cut it from both directions more than 6? If we cut it, our square would look like that. And that doesn't work. That doesn't give you like a box. That's why the volume is negative. Does that make sense? So you should be getting a negative volume. It's one that algebra makes it work, but it doesn't actually in real life. Like, do y'all remember problems like that from Algebra 2? You would square both sides and get x minus 5 equals 4, and so x equals 9. You remember that kind of problem? But if you plug it in, 9 minus 5 is 4, square root of 4, is that equal to? Like, your algebra made you get an answer, but it doesn't actually work in the problem. This is the same kind of thing. Like, you get it because of your algebra, but it doesn't actually work in real life. Does that make sense? So it wasn't wrong, the 6.74 wasn't wrong, it just doesn't actually work. Yeah. Any questions on these? Okay, so whenever you're looking for max area, what do you start by doing? Okay, you find an equation and you take the derivative. Then what do? How do you do that? Set it equal to 0 and solve for x. And then what? Yep, you plug in your critical numbers and figure out which one is actually going to work in the problem. Does that make sense?
Yep.
On word problems, if you don't know what to do, make an equation and take the derivative and set it equal to 0. Usually that'll help in some way, for now. Does that make sense? Okay. Oh, we didn't actually get an actual answer.